total count and the total mass of firebrands generated from each structure burn experiment by using the sampling data and statistic modeling. And for example, those lower wind speed tests ADU 3, 4, 5 with different siding material, but 35 mile per hour wind, estimate the total count like 2 to 3 million. But for the higher wind speed, ADU 7 with 55 mile per hour wind, we estimate there are like 6.5 million firebrand, total firebrand generated and deposited. By also averaging this with the sampling, firebrand sampling duration, we get the firebrand generation rate. And we find the higher wind speed, 55 mile per hour, is actually triple the number and also mass generation.
I mean, there's no way to collect that during an actual spreading wildfire. It's too dangerous. There's too much going on. There's certain things you can collect after the fact. But to be able to summarize that, because we had the chance to set up and catch so much data, I think was really important, because we're missing, you must call it a source term. Like, we don't know how much to start with. But when you hear those numbers, you then realize embers are going to be everywhere. And so, does that mean we need to track and model every one? Of course not. But how big could they be? How far can they get? And what can they ignite? Now we have more data to do that and to try to make sure that the materials downstream are harder to ignite and won't ignite under that, or at least to estimate the risk that they will, based with what we have.